Namaste, good morning friends. Today we will study JK flip flop. Last time you have studied SR flip flop using clock pulse. So the continued chapter, again we are just going to study JK flip flop today. So please listen carefully. It's very important to know about the flip flop. So what is JK flip flop? First of all, here is the small definition. A JK flip flop is nothing more than an SR flip flop with an added layer of feedback. We will see in the circuit diagram how this JK flip flop is developed by SR flip flop. And JK flip flop is also known as universal flip flop, because by the help of this JK flip flop we will study JK master slave flip flop, D flip flop, that is the delay flip flop, and T flip flop, that is the toggle flip flop. So we have to see a lot of flip flops. So firstly, see how this JK flip flop, the full form you can say that Jack Kilby. And here first of all I am going to make SR truth table. So just remember the truth table of SR truth table. In SR truth table we have studied while the clock is 0, then S may be 0 or R may be 0 or 1, whatever. This is the don't care condition. We are represented by the X marks or cross marks. If clock is 0, S is equal to 0 or 1 or R is equal to 0 or 1, we have seen that that was the last state, that the value of Qn, and we can say that is the hold state. Just remember that. And if the clock is 1, there may be the 4 condition, because the 2 inputs, so 0 0, 0 1, 1 0 and 1 1. And when the clock pulse is 1, what we have seen that when the clock pulse is 1 and S is equal to 0, R is equal to 0, then Qn plus 1, that is this is the next state. The next state will be the Qn, what was the last one. So we can also say this is the hold state, memory state, previous state, all we have known. If this is 0 1, so here will be the 0, and that condition we will say that reset condition, RESET, reset condition. And if the S is equal to 1 and R is equal to 0, so we output the next state Qn plus 1 is equal to 1, and that we have said that this is the set state. And when the S is equal to 1 and R is equal to 1, this is here is invalid. We can say there is the question marks, or we can say this is invalid, or we can say this is the cross. We don't know what is there, because Q is also the 1 and Q complement is also going to be. This is our, you have just studied, तपाईहरुले अहिले भर्खरै पढ्नु भएको छ. This is our SR, this is our Qn, and this is Qn complement, because this is the SR flip flop, and here is the clock pulse, CL. You have studied this in the last chapter, last lesson, and the help of this we will create the JK flip flop. So nothing is to worry, just we will add only the AND gate in the circuit, and we will give the feedback. So in the circuit, suppose we are adding here, this is the AND gate, so 2 AND gate, and this point is J, this point is K, and this is the our CLK, that means you know this is the clock pulse, we are replacing by this clock pulse here, and the output of Qn is कनेक्टेड और फीडब्याक हामीले जोडेको छौं यसमा र त्यस्तै यो the next another line, the output of QN complement is connected in the J. But this much, this is the circuit, you can say QN and QN complement, and this is the full circuit of JK flip flop, you can say. Now see this point, we can say S and R. So if this is QN complement, so we can write here QN complement, very easy, and this point is QN, so this is our QN. Good, very good. Okay, now so the what will be the value of this S? So you will see the value of this S is equal to J dot, that means the multiplication QN complement, QN complement, and the value of R, this point is represented as R, so this is the K, by the AND gate K dot, and this is the QN. Okay, so this is the block diagram of SR flip flop using AND gate. And you know very clearly in this there is, we have made the SR flip flop, and this is the truth table of SR flip flop using NOR gate. Now we will see the characteristics table of JK flip flop. So see, listen carefully, I am going to make the characteristic table of JK flip flop. So in this, what are the important point? Firstly, our input, this is J, and the next state which will be the output, this is our QN plus 1, and you can see also the comments. This is the characteristics table of JK flip flop. We have to learn very carefully, and from this table we will generate the truth table of JK flip flop. So firstly, what I am to say, ki this J and K are our input terminal. So firstly, J should be 0, K should be 0. We have our two options. What are the options? We have two options, J is equal to 0, K is equal to 0. On that time we have to assume, what we have to assume? Qn may be 0 or 1, Qn may be 0 and 1. So suppose first time the Q is 0, then Q complement is itself 1, no problem. And if Qn suppose 1, then Qn complement is 0, and on that time the J is equal to 0 and K is equal to 0. So when the J is equal to 0, K is equal to 0, on that time there are the two options, the Qn may be the 0 and 1. So we will see this both the line, what will be the output. So firstly, I think here in this table S is equal to here J dot Qn complement. So what will be the output if we will apply here, J is equal to 0, K is equal to 0, Qn is equal to 0, we are assuming that 0, so Qn complement is equal to 1. So what will be here? Here the Qn complement will come 1, and here the Qn, from this the Qn will come 0. So S is equal to, here the output S is equal to J dot Qn. So see here in this table, this J and Qn, so we should multiply, we should multiply J and Qn, because in this equation already this is written. So J is, if J is equal to 0 and Qn complement is equal to 1, so 0 into 1 is equal to 0, and R is equal to K dot Qn. So see this both table, so we should multiply this table k into qn, and k into qn is equal to 0 into 0 is equal to 0. So, when our S is equal to 0, R is equal to 0, in the truth table of SR flip flop, we will see S is equal to 0, R is equal to 0, clock pulse is equal to 1, already we have given. On that time, what is the next value? Qn plus 1, that is the Qn, that means it was the previous state. So, in this, what was the our value of S? Qn, the value of Qn is equal to 0. This is the previous state. So, we can easily write Qn plus 1 is equal to 0. Now, when the Qn we will suppose, we will cut this, we will suppose, we are assuming that Qn is equal to 1, then the Qn complement will be the 0. When Qn is equal to 1 and Qn complement is equal to 0, again the same process will go here, and S is equal to, we will see that S is equal to J into Qn. So, this table, so here the 0, J is equal to 0 and Qn complement is equal to 0. So, 0 into 0 is equal to 0, and k into kn, so 0 into 1 equals to 0 into 1 equals to again 0. So, the Qn, again the next state. So, what was the next state? 1, here is the 1 next state, see, because you have assumed that this is the Qn is equal to 1. So, here the output will be 1. That was the next state. So, we can say this condition, this both condition was in the hold condition. Okay. Again we will see when this j is equal to 0, k is equal to 0, now we will put j is equal to, we will put j is equal to 0, k is equal to 1. Again there will be the two options, Qn is equal to 0, Qn complement is equal to itself 1. And if again this is 0, this is suppose 1, so what will be the condition, and Qn is equal to 0 because the complement of this, so let us see. Now, the value of j is equal to 0 and k is equal to 1. Are you understanding? Okay, any questions, any query? No, very good. Now, see, if again the formula j and qn complement, so this and this is equal to 1, 0, so this will be the 0, and again 1 into 0 equals to 0. Now, when we are supposing that Qn is equal to 1 and Qn complement is equal to 0, on that time 0 into 0 is equal to 0, 1 into 1 is equal to 1. I am taking both the two conditions at the same time, because we are assuming Qn is equal to 0 and next time Qn is equal to 1. So, while the Qn is equal to 0 and Qn complement is equal to 1, here the Qn is equal to 0 and Qn is equal to 1, j is equal to 0, k is equal to 1, on that time what will happen here, s is equal to 1 and this is 0, and this condition we will see in the SR truth table, when s is equal to 0 and r is equal to 0, then there was the Qn, that was the hold condition, what previous. So, s is equal to 0, so this is the previous, so we should write the 0. Now, the next condition, when the Qn is equal to 1, and this is equal to 0 and j is equal to 0, k is equal to 1, and clock pulse is already, every time the clock is 1, because in the 0 condition the clock always give the hold condition. So, when the clock is 1, only the output is going to give by the AND gate. So, now here we will see the next state, when s is equal to 0 and r is equal to 1, s is equal to 0, r is equal to 1, in this condition the next state is the 0. So, again we will write the 0. So, what you have seen that in this same condition, when j is equal to 0, k is equal to 1, again this circuits give the 0 0, and this condition we will say that reset condition. Whatever the Qn will be 0 or 1, whatever you will assume, the output will be reset. Now, the next state, we will see j is equal to 1 and k is equal to 0, j is equal to 1, k is equal to 0, and suppose Qn is equal to 0, we are assuming that Qn is equal to 0 and Qn complement is equal to 1, because we have the two options, again we are making the two options, again we are putting 1 and this is the just opposite. So, what will be the value of S and what will be the value of J. So, by the same multiplication table, very easy, we can see multiply this and this, J into K into Q complement, 1 into 1 is equal to 1 and 0 into 0 is equal to 0. Again for this 0 into 1 is equal to 0 and 0 into 1 is equal to 0. So, while the J is equal to 1, K is equal to 0, Qn is equal to 0 and Qn complement is equal to 1, on that condition S value is 1 and the R is equal to 0, what we will say? If S is equal to 1 and R is equal to 0, the condition is the set condition, that is the 1. Again, when J is equal to 1, K is equal to 0 and the value of Qn is equal to 1 and Qn complement is equal to 0. So, again what is here? 0 and 0. So, in this condition, when this is 0 and 0, so what will be the value? If S is equal to 0 and R is equal to 0, so the hold condition, so this was the Qn previous condition. So, on that time the value of Qn is equal to 1. So, 1. Listen carefully, do not be confused, because it is very easy. S is equal to 0, see here, and R is equal to 0. S is equal to 0, R is equal to 0, and that time this was the Qn plus 1 is equal to the previous state, whole state Qn. What was the Qn? On that time the Qn was the 1. So, I have written the 1, and this condition is known as set condition, because the output is 1. So, this is known as the set condition. And the last one, if here if J is equal to 1, K is equal to 1, here is also the two condition, two value. On that time we are assuming initially Qn is equal to 0 and the next time 1. So, the Qn complement will be just opposite of the Qn. So, this on this time again 1 into 1 is equal to 1, 1 into 0 is equal to 0, 1 into 0 is equal to 0, 1 into 1 is equal to 1. Now, what will be the next state? So, S is equal to 1, R is equal to 0, S is equal to 1, R is equal to 0, S is equal to 1, R is equal to 0, the 1. So, we will write here 1. And when our J is equal to 1, K is equal to 1, on that time Qn is 1, 0, the value of S is 0 and R is 0. So, 0 and 1, we will see 0 and 1 this. So, the reset, so the 0. So, by seeing this table, what we are going to find here, when our output is 1, on that time the value of Qn is what? 0 and here is 1, and if here is 1, the output is 0. So, we can easily say that while J is equal to and K is equal to 1, on that time this circuit, when the input is here is 0, then the next state is 1, and when there is 1, then here is 0. So, the output is toggling. So, we can say in this state toggle. This state is known as toggle, or also we can say race around condition. Race around condition. What is race around condition? It is very important. In this JK flip flop, what we have seen, ki whatever the value of SR flip flop, same the value is also in this, only while the state is J is equal to and K is equal to 1, only that was the change. And we are facing that problem in SR flip flop, ki when that S is equal to 1 and R is equal to 1, that was invalid. But in JK flip flop, what we have got, that this was toggling. While the value of J and K is equal to 1, the value is toggling, not invalid, value is toggling, or we can say the race around condition. And what is the race around condition, we will see. Before that, by the help of this characteristics table, we will draw the characteristics. What is the characteristics of JK flip flop? How we will find? So, it is very easy. Firstly, we have to see here, I am going to draw the characteristics. For that, we have to make the K map. So, there are the 3 inputs for the JK flip flop in the, so 8 output So, we will draw the K map. This is the K map. You know very well what is the K map. So, our inputs are J, K and Qn. These are all three are the inputs, and we know this is 0, this is 1, 0 0, 0 1, 1 1 and 1 0. We are using the grey code here. Do not be confused why this is 0 1, why not 1 0, because we are using the grey code, and this the value of j means j complement and 1 means j, and this 0 0 means k complement and k qn complement, same as k complement kn, k qn, k qn complement, and the name of the cell, this is M0, M1, M3, M2, M4, M5, M7 and M6. So, now by the help of this characteristics table, we should put the value in this K map. So, see, when our JKQ, see this in this table JKQ, in this I am drawing this one cell, this table, when the value of where there is 1 qn 1, when this is 0 0 1, in the 1 number we will mark as 1. So, here will be the 1, this we have to see this output, this output, this output. Okay. Now, this 1 is where 1 0 0 and this means the 4. So, in the 4 number, this is the 4 number, cell number 4, again this 5 number. So, here will be the 5 1 by using the soft form, and the last one, this is in 1 1 0, this is the 4 2 1 6. So, this is our input in the K map. Now, make the loop. So, the loop is this 2, we can make one loop, very easy, and this half and this half is the one. So, this is the one loop, loop number 1, and suppose this is loop number 2. We can give the name as you wish. So, the output, what will be the characteristics output of JK flip flop? So, Q n plus 1 equals to the output of loop number 1, we will see this is not matching. So, this k complement qn plus loop number 2. So, by this way we will see this is the j, and by upper one this 0 not matching this and this is qn complement. So, this is our characteristics table. So, the JK flip flop equation. By this way we have solved this, and the major thing is what? Now, the final truth table of JK flip flop, by the help of this characteristics table, what we are going to design the truth table, because you may, what is the conclusion came from this characteristic table, that we will write here. If clock is equal to 0, then we know very easy, j and k, the value of j and k will be the 0 and 1 whatever, this will be the qn, matlab whole position, whole state. If clock is equal to 1, then there will be the 4 conditions 0 0, 0 1, 1 0 and 1 1. So, very carefully, very easily, I think you will understand. Now, from this table we will see when the value of j is equal to 0 0, we will see in this 2 0 0, k is equal to 0, j is equal to 0, what was our the final answer? Whole state. So, we can easily write this will be the qn and whole state, means what was the previous, if the previous was 0 then 0, when the previous was 1 then 1, and that condition we can easily say that this is the qn. This is the qn. Again, when the 0 and 1, in this condition 0 and 1, then what is the value? 0 0. So, we can say this is the 0 and this is known as reset. And when the value is j of k n is equal to 1 0, we have seen that 1 1. So, we can say this is the 1 and we can say this is the set state. And finally, when the 1 1 j was 1 and k was 1, on that time we have seen that the just opposite of the qn, and we say this is the toggle. So, we can write here qn complement. What was the qn? If 0, then this is 1, then 1, this is 0. So, we can say that qn complement, and this is known as the toggle. So, this is the k map of, this is the truth table of JK flip flop. And one table is also there, that is a excitation table. So, that table is also important. You want to see, just see it, excitation table, very easy. Excitation table. So, now I am going to rub this due to the less space on the whiteboard. I think you all are getting very well. Are you getting any bored? Any questions, any queries there, then please ask. Okay, the difference between the JK and SR is only one, that in the three condition, in this all the condition is the same, but only when the J value of J is equal to 1 and K is equal to 1, on that time this JK flip flop is going to toggle. And what is the meaning of toggle? The meaning of toggle is when we are assuming here 0, the output of Qn is 0, on that time the process will come and lastly it will be the 1, and 1 becomes 0, 0, 1, it continually changing 1, 0, 1, 0, 1, 0, 1, and this is the just opposite. So, this is continuously going from 0 to 1, 1 to 0. So, this process is known as the toggle process. Okay, thank you. Okay, let us see the excitation table. What is the excitation table? So, in excitation table there are also the Qn. From in this table we will make from output to input, the relation between output to the input. So, Qn and Qn plus 1. So, what will be the value of Jk? And this is also drawn from the excitation table. So, see very carefully. So, in excitation table, while the value of Qn and Qn plus 1, when this is the output, so there will be the only 4 condition maximum. So, it may be the 0 0, 0 1, 1 0 and 1 1. यो बाहेक अरू केही condition हुन सक्दैन. There are only the 4 possibilities, because we have the formula 2 raised to n, and the value of, if the input is 2, then 2 to power 2, that will be the 4. So, these are the 4 values. On that time, what will be the value of Jk? So, see here very carefully, when the value of Qn and Qn plus 1 is equal to 0 0. So, here we will see the value of Qn is, see here Qn is 0 and Qn plus 1 is also here. Now, this is 0. On that time the value of J and K is 0 0. So, here this is 1, see carefully. Again here is 0 and here is 0. Search any more? No, only the 2 condition. Qn value is 0 here, Qn plus here is 0, here 0 0. On that time the value of J is what? 0 0. The value of J is what? 0 0, and the value of K is 0 1. So, we can say if the value of J is same, so the value of J is same is 0 and the value of K is changing 0 to 1. So, we can mark as X, that is the don't care condition. Now, the next, when the value of Qn and Qn plus 1 is 0 and 1, on that time what happens? So, see 0 and 1. So, find in this 0 and 1. No, here is this 0 and this is 1, another here is 0 and here is 1. On that time, if you will see, the value of J is 1 1, the value of J is 1 1, see here, and the K is 0 1. Again, we can write here 1 and 0, no, 1 and X, because the value is changing. This is our excitation table of JK flip flop. 1 0, see in 1 0, 1, here is the 1, now this one red one 1, and here is 0 in Qn and Qn plus 1 we are seeing 1 0 1 0, okay, the red one aru chaina hamro yaha. So on that time here this is 1 0, on that time we will see what is here, the value of j is 0 and 1 and the value of k is 1 1. So this is the x and this will be the 1. So this will be the x and this will be the 1. And the last one, when the 1 1 Qn is equal to 1, here 1 1, again the next one, here is the 1, else no, and that time this time 1 1 and the 1 1. So the value of j is equal to 0 1, this is toggling 0 1 and the value of k is 0 0. So this is the fix. So x 0, that means this, and this is the excitation table of JK flip flop. So we have already seen how the JK flip flop is developed from the SR flip flop. This is the SR flip flop. We have just added AND gate and feedback to the AND gate. We have firstly made characteristics, after that characteristic equation by the help of K map, then truth table, this is the excitation table, and the last one, that is the race around condition. So little bit I want to describe the waveform of race around condition, how it happens. So let us see how this happens. So there is positive is trigger and negative, this is number 1, this is number 2, this is 1 and this is 2 trigger. So among these 4 we can apply any one, but the reason is what? First of all, this is eliminated, the race around condition will be eliminated by the ace trigger. This problem is solved in also JK flip flop very easily, but we are not solving here because we are applying the level trigger. So what is the difference between level trigger and ace trigger? Level trigger is this area. This area is known as the level trigger. This is the positive one. This is negative one. This is rising edge and this is falling edge. So the process problem is here what? We are applying the level trigger, level clock pulse. This is represented by this. So when the clock is 1 from goes on that time in this circuit, in all the rest condition, the 3 condition, when this is 0 0 0 1 1 0, on that time here the output will come. When this is 0, it will come in the hold state, reset state and set state. And while this is 1, on that time what happened on the shortened time? Suppose this clock pulse is in nanosecond, the level of this clock pulse is suppose 5 nanosecond. So in the duration of 5 nanosecond, what happened? The changes of here what it is changing from 0 1 1 0 1 0 1 in 5 seconds it is changing 1 to 0 0 to 1 0 to 1. So this is the changing, and when the clock is 0, again when this cycle goes, on that time it will be a stop. Again the clock is high, on that time again 0 1 0 1, this is 1 0 1 0 1 0 1 0, the clock is high, on that time this is oscillating, we can say oscillate, and that condition is known as the rest condition. So there are the 2 options in which we can control this, the toggling mode. One is what we will see in the next lecture, that is the MS JK flip flop, that is our master slave JK flip flop. So this is the one process, and the another is ace trigger. age triggering. If in the 5 nanoseconds, suppose if this is triggering 5 times or 10 times, if the level of the clock pulse will be decreased, then itself it will be controlled. So, we can make by the both option, but we have to see in the level triggering what will happen if the level triggering pulse will go to the different flip flops. So, this problem will be solved into JK master slave flip flop. So, I think you all students, dear friends, you are very well known what is flip flop. Firstly, we have seen by the latch, in latch there was no clock pulse. By the help of NOT gate, we have seen the latch. In the NOT gate, what was the problem? That we can't give the input to the flip flop. So, further we have moved towards the NOR gate. By the help of NOR gate and the NAND gate, we have made the SR latch, and in that we have seen in the 4 conditions 0 0, 0 1, 1 0 and 1 1, the 3 condition we have already cleared. We are seeing the hold condition, reset condition and set condition, and SR latch there was the problem that there came the invalid condition. So, while the S and R is equal to 1 1, we got the invalid. So, we have moved towards JK flip flop to solve that problem, but in JK flip flop it was solved, but not totally solved. While the J is equal to 1 and K is equal to 1, it was toggle. Little bit it was solved, but totally not solved. So, again we are not satisfied with this. So, we will move towards the next flip flop, that is our master slave JK flip flop. So, we will see in that. For today, this much only. I hope you all will understand. If there is any query, any questions, you may ask, you may comment anytime. So, thank you all dear my friends, all the best in your future. Thanks a lot, bye.